Welcome. In this video, we will be discussing the for loop in MATLAB. The for loop is a useful operation that is used to loop over a block of code a known number of times. We do this so that when we have similar calculations to process, we can just use a for loop to repeatedly execute them instead of having many chunks of similar code. To show you this, I've constructed a short example based on the force calculation in week 1. To demonstrate the for loop, we're going to step through this program in the debug mode as was introduced in the first week. Before we start that, I have modified the force calculation program just a little bit to enable us to do some for loop calculations. I have changed the mass variable to be a vector. If we have commas separating the data points in the vector, that means we're producing a row vector. If I put a breakpoint here, execute the program, we will see we've stopped here and executed these 3 lines of code, indicated by K. We're in debug mode, and mass is, as we said, a row vector. I've defined 9.81 to be the acceleration of gravity g. It's useful to define constants in MATLAB such as g. There's also constants such as pi. And a note for the future, there are complex numbers I and j. What I've done here is, with the force computation, I have defined an array that is 0. I've done this because once we enter a for loop and we're repeatedly doing this calculation from last week, it's useful to have pre-allocated memory to save our answers instead of continually slapping on bits of data onto an array. So what I've done here is I've used the zeros function. If we copy this line of code, I've used the zeros function, and that produces an array according to the dimensions that we provide to the input. So there's 1 row, and the number of columns is defined as length of mass. I introduced the length function in a previous screencast, and our variable mass is up here. So zeros will be 5 zeros in a row vector. So once we do these computations, each of these elements in the force will be filled up with our answers. Pre-allocation is a good practice to start doing when you're writing your own programs, and I strongly encourage you to use it yourself. So let's look at this for loop. The format of a for loop is as follows. We have the for keyword and the end keyword, just like the if statement and switch statement. The end keyword is commonly used in all of these. The for keyword is followed by this section of code. This section of code is what controls the number of times this block of code inside the for loop is executed. This variable is what we call a counter variable, or perhaps an index variable. It's called a counter because the values we provide to it change each time a loop is executed. If we just copy this section of code, we can see what we've exactly provided to the for loop. If I clear this screen and paste that code, we see that n is 1, 2, 3, 4, 5. So it's a row vector from 1 to 5. What this has told the for loop is that for some variable called n, we're going to repeat this calculation 1, 2, 3, 4, 5 times, and each time a loop is performed, the value of n is going to take each of these numbers. So the first time this loop is executed, n will be 1. Once all this is executed, we go back to the start, n will be 2. We execute this, n will be 3, execute this, until we get to the end, where n takes the value of 5. This chunk of code is executed, and since 5 is the last number in the provided vector, that means the for loop is finished, and so the end keyword is used to finish the looping process. So to demonstrate what's happened here, let's actually leave the breakpoint there. Let's exit debug mode and run the program again. Let's just clear that. And now let's step through the for loop. Using the step command, we're going to go down here to this line. We've entered the for loop. Note that nothing has changed in here, except that the value of n has been defined as 1. If we step again, we're going to execute this line. So we see that the value of force has changed for the first element of the force vector. We're going to step again and execute this line of code. Don't worry too much about this little guy in here, because we will cover this in weeks to come. But for now, I've included it because it's a useful way to format the output nicely. Once that's been executed, we're going to enter an if statement where we check force n, that is force n, which is 24.525, which is the calculation we've performed. This is all the same as last week. So we're going to step in here. Force is 24, which is much less than 200. So we're going to jump in here. Display force is, display the numerical value of force, and we're at the end of the if statement. We're at the end of the for loop, and we're going to jump back up to the start. See that n now has changed to 2, which means we've done one loop of the for loop, and now we're entering the second loop. With n being changed to 2, we're going to execute this computation again. Force, we can see, has changed, and so again this code will be executed. The if statement will be executed. 49 is much less than 200, so this chunk of code will be executed. And we're going to be into the third loop of the for loop. If we continue the program, it's going to pick up from where we were in the debug mode and continue the program for us. So where we left the debug mode was here, and the last two iterations of the for loop have been performed as MATLAB would in normal computation time. So the third loop has produced this result, the fourth loop has produced that result, and the fifth loop has produced that result. As we can see in this example, the counter variable that we have provided in the for loop, this is the variable that monitors the amount of times a for loop is performed. The amount of times it's performed is governed by the vector provided here. And I should make it clear that what we've used here, where n equals 1 to length mass, it does not have to be 1, 2, 3, 5 in order. It can be anything. So if we wanted to use a for loop, and instead of using n, we wanted a variable called count, we could in fact use anything in the vector. So we could use 54, negative 43, we could even use pi. We can use operations, and this vector would be passed to the for loop, and each of these values would be taken on by the counter variable count, and it would be used inside here. As I just said, we may use the counter variable inside the for loop, and as we've seen here, we've performed linear indexing into the force and mass vectors to pick out bits of data. So we can use the counter variable inside the loop, and it's useful for referencing data from arrays. A quick note is that if we do change the counter variable inside here, once the loop has been finished and another loop is to begin, any changes we've made will not be remembered by the for loop. So if we, at the end, let n equal 56, if we put a breakpoint here, remove that breakpoint and execute the code, we're going to see that n is 1. If we step into here, we see that n is 1, and if we step there, we see that n is 56 as per this command. If we step again to the end of the for loop and up to the start again, n has been changed back to 2 as governed by this for loop. So keep this in mind when you're using them. A quick final note is that if you have done any programming before, you may remember that a common name for the counter variable in for loops is I or j. This is common in programming languages like C, C++, and Java. In MATLAB, using the variable I or j is not a great idea because, as we saw before, I and j have predefined values in MATLAB. They correspond to the complex number I, which is the square root of -1. If you're not familiar with that, don't worry. The important message is that I and j are predefined in MATLAB as other variables, so I would not recommend you using them as counter variables for your for loops.